In the figure, two blocks are separated by a uniform strut attached to each block with frictionless pins. Block A weighs 400 newtons, block B weighs 300 newtons, and the strut AB weighs 200 newtons. If mu is equal to 0.25 under B, determine the minimum coefficient of friction under A to prevent motion. So we have the strut in the left side diagram over here, and AV and AH are the forces acting on it from block A in the vertical and horizontal direction, and similarly BH and BV are the forces acting on strut from block B in the horizontal and vertical direction respectively. We have 200 newtons acting on the center of mass, which is the weight of the strut. In the case of no motion, there would also be no acceleration or no angular acceleration, and thus the net forces and torques on the strut must be equal to 0. What is the net force in the vertical direction on the strut? We have AV plus BV minus 200 newtons, and this must be equal to 0. What is the net force acting in the horizontal direction on the strut? AH minus BH, and this must also be equal to 0. Now, what is the torque acting on the strut? Let us say the length of the strut is L, and let's calculate the torque about point A, or rather point of contact with the block A. So that would be 200 into L by 2 root 3 by 2. This is the torque acting due to gravity. Then we have minus BV L root 3 by 2 minus BH L into 1 by 2, and this must be equal to 0. This simplifies to 100 root 3 minus BV root 3 minus BH is equal to 0. Now moving on to block B. Let us set the net force in the vertical direction on block B to be equal to 0. So that would be 300 plus BV would be equal to NB into cos 60 degrees, which is 1 by 2, plus 1 by 4 NB into sin 60 degrees, which is root 3 by 2. And then we have the forces in the horizontal direction on block B. So that is BH plus 1 by 4 NB into cos 60 degrees, that is 1 by 2, is equal to NB into sin 60 degrees, which is root 3 by 2. Now let's move to block A. The equations for block A are rather simple. We have NA, which is the normal reaction on A, must be equal to 400 plus AV, and you also have AH is equal to mu times NA. So now we have 7 equations. Here's equation 1, here's equation 2, here's equation 3, and here are equations 4 and 5, and here is equation 6 and equation 7. And you also have 7 variables, which are AV, AH, BV, BH, NA, NB, and mu. And mu is the variable that we have to find. With 7 equations and 7 variables, we can find mu, and it turns out to be option A, 0.4, which is the correct answer.